Okay, so that was the hard diamond method again, and now what we're going to look at is we're going to look at the slightly easier version, when that first number is equal to 1. So we can always do it the hard diamond method. In fact, a lot of people would prefer that you do it that way, but just because it's in the book, and we've taught it this way before, and I learned it this way, I'll also show you an easy diamond problem. So I'm usually pretty good about making these up off the top of my head, so I'm going to try that. I reserve the right to make a fool of myself and come up with one that doesn't work. Let's go with this one. So we're going to factor x squared plus 2x minus 35. Okay, so not necessarily easy, but what we do is we know this is an easy diamond problem because the first number here, there's nothing written there. It's really just like a positive 1. So positive 1 is nice. It means that everything's going to work out nicely. So this tells us that it's an easy diamond. Okay, and what we're going to do is for the easy diamond, we're just going to actually set up a diamond. So here we go. Make it a little bigger. I know I've got less work to do here. Got to figure out what two numbers this is. We'll multiply to the first number times the last number, and then add up to the middle number. Okay, so first times last, well, it was positive 1 times negative 35 is negative 35. And the middle number is positive 2. So the question we ask ourselves is, well, what the heck numbers are going to multiply to negative 35 and add up to positive 2? So if you don't see it right away, you might see it. I do see this, even though, well, of course I do because I made up the problem. But if you don't see it, we can look at factor pairs of 35 and try and see which ones might work. So I know 1 and 35, that's not going to work. Add or subtract doesn't add up to 2, or subtract to 2. Other than that, 35 is 5 times 7, so 5 and 7. See, that could work because they're 2 apart. So I'm thinking this is going to have to be a 7 and a 5. Okay, so now to figure out the sign, since they have to multiply to be a negative, well, it's got to add up to positive 2, so the bigger one has to be positive. And there we go. So our two numbers there are positive 7 and negative 5. Now, because it's an easy problem, we can actually jump right down to our answer, but let me actually show you why we can jump to our answer. So if we were to do the step like we did before, we would write out our polynomial as x squared plus 7x minus 5x minus 35, and then we'd split the middle and factor it again. So here our GCF is going to be x. We'll be left with x plus 7. Over here, it's going to be, minus 5, and then on the inside we're left with x plus 7, and so our final answer would be x plus 7, x minus 5. Now what you can see here is that our final answer actually has the pieces directly out of the diamond. So it was x plus 7 and x minus 5. So on an easy diamond problem, you don't even really need this step. Like if you recognize it's an easy diamond, you can skip these two steps. Just kind of go blah, cover them up, and just, it's awkward, just jump right to your final answer. But hey, there's nothing wrong with doing the full hard diamond part, the split in the middle step. That's why it works. Okay, so that was the easy diamond, so-called easy diamond. We have one more strategy to go through here. This is one that's probably the most comfortable for most people, and that strategy is going to be the difference of squares. So number 4, difference of squares. Okay, and it's very quick to recognize when you have a difference of squares, because unlike our other problems here that we've done, although again you could have a GCF problem, this one always has two terms. Okay, we got two terms here. And I'm going to give you one that actually has a GCF in it, just because I feel like that might be a good thing to do. So, let me see. Okay, I'm notorious for messing these up. Okay, there we go. I think this one's going to work. Cross your fingers. I think it's going to work. Okay, so in order to do this, the first thing we have to do for any factoring strategy, but the only time I'm going to actually show it is here, is we got to pull out a GCF. So we've got to look and see, is there a GCF here? And the answer is there definitely is a GCF. 20 and 45 are both multiples of 5. So if I were to actually break this up, know what, I'll just kind of draw a GCF table over here. 20x squared and 45. This is 2 times 2 times 5 because it's 4 times 5. X times x. And this would be 9 times 5, so 3 times 3 times 5. So if we look here, my GCF is going to be 5. So this expression can immediately be factored into 5 times, well, whatever's left. I've got 2 times 2, 4x squared minus 9. So there we go. We've started by GCF factoring because there's a GCF in there. Now for the actual difference of squares. So let me just kind of point out again that was a GCF. For the actual difference of squares now, we got to recognize that inside the parentheses here, we've got something squared and something squared. So on this next line, I'm going to kind of make it big. So I'm trying not to forget my GCF. So here, we've got to answer the question, what stuff is being squared? Because our method for difference of squares relies on that. Well, when I look, obviously the square root of 9 is going to be 3. So I'm going to write that in there right away. And then for the other one, well, the square root of 4 is 2, and then the square root of x squared is x. So I've got 2x being squared minus 3 squared. And so what this does is my final answer, anytime you do a difference of squares, is, well, here we've got our GCF. We're going to have something times something, or stuff times stuff. One's going to be positive, one's going to be negative. Okay. Then you know what, just for simplicity, I'm going to change the color of this guy so you can really see it. So that's 3. Okay, so now, how do we fill in these factors? Well, we just take the pieces out of right here. So it's going to be a 2x for both of them in front, and then it'll be plus 3 and minus 3. And there is a difference of squares factoring. So obviously, again, we used a GCF. We had to pull out a GCF here, but that shows the difference of squares method as well. So the difference of squares itself is right from this piece with something squared minus something squared, and those two somethings fill in our two factors, one with a plus, one with a minus. Alrighty, so what I'm going to do now is I'm going to illustrate for you two more examples, one of difference of squares and then one of a hard diamond combo GCF, so a little bit of everything in it, like the hardest possible problem we could give you. Okay, so for my final piece, I'm going to go through a problem that asks you to use the hard diamond as well as the GCF. So to start off with, when I first look at this problem, you know, let's say I just got the standard quiz I'm looking at, it's number 9, I'm excited about being finished because it's Friday. What I see is that I've got 6x cubed plus 22x squared plus 20x. So what tells me that this is probably a GCF factoring piece, like I've got to do some GCF work, is that 6, 22, and 20 are all even numbers. So you can definitely know for sure that 2 will come out. And there's an x in every one of these terms. So I'm going to have to pull out that x also. So to start off with, if I'm not comfortable with GCF, I can actually start by just creating a little table, figuring out what my GCF actually is. So I'll do that since I'm doing a full example here. So 6x cubed, 22x squared, 20x. I don't know why I put that plus there that time. I usually have it. And okay, so for prime factoring each of these, 2 times 3x, x, x. Here we got 2 times 11, x times x, and then 2 times 2 times 5 times x. Okay, so to find my GCF, I've got to cross out everything that's in common to all 3 of them, not just any 2 of them. So I see that there's a 2 right there, that's in all of them, and I see an x. So my GCF is going to be 2x, so I'm going to have to keep that with my problem. And now to fill in the rest of this, I've just got to fill in the leftovers from the table. So looking at my table at the top, so you've got 3x squared. All my signs are pluses, so I'll keep them both plus. 11x, 2 times 5 is 10. And so there we go. We've got our problem already GCF factored. Now what we need to do is, this could be our final answer. It could be. I know it's not going to be because I designed the problem. But this could be our final answer. But in order to know for sure, we have to check and see if maybe this is a hard diamond one. So I'm going to set up the diamond. So let's see here. So we've got first times last, so that'll be 3 times 10 is positive 30. And the middle number is positive 11. So what two numbers multiply to positive 30 and add up to 11? Well, I can tell this one for sure. It's going to be 6 and 5. So inside here, I'm going to get positive 6 and positive 5. So now what I've got to do is I've got to break up this piece. So I'm just going to look at that spot. So I can't forget my GCF. I don't want to forget that guy, but I'm going to work on the spot. So if I split the middle, it'll be 3x squared plus 6x plus 5x plus 10. And now splitting the middle, trying to juggle all the pens here. So I've got to split it up right here. Got to pull out a GCF from each one. So what do I see? Well, here 3 and 6, GCF is going to be 3, and we'll get an x coming out. What am I left with? I'm left with x plus 2. On this one, I can see I can pull out a plus 5. Be left with x plus 2. So from here, this guy, hard diamond factors into x plus 2, and this guy times this guy, or plus this guy, 3x plus 5. And then I'm not done though. My final answer isn't complete unless I include the GCF. So you need the GCF, and it needs you. So I can't forget to plug that in over on the side with it, right out in front. So now I've got GCF times the hard diamond factored polynomial. So my final answer is 2x times x plus 2 times 3x plus 5. Definitely involved, but not beyond your ability level. Just know what you're looking for and you'll be okay. Alrighty, so I'm not going to do another example of the difference of squares because I'm kind of tired of factoring right now. So hopefully this video has been helpful, and question number 9 a little less intimidating. Have a good night.